Hi everyone, this is Jack from Maths Forge, and in today's lesson we're going to be doing composite functions. A composite function is essentially a function of a function. So here we have the function g of x, which is equal to 7x, and then a different function f of x, which is equal to x cubed. And we're being asked to find g of f of 2. So how does this work? Well, you have g of f of 2. You start with the number 2. This number is going to be input into the function f. Once it's input into the function f, you end up with a value. And let's see what that value is. So let's take our f of x, and we're going to replace the x with a 2. Now, f of x is equal to x cubed. Since the x was replaced by 2, the x cubed is now going to be 2 cubed. And 2 cubed is equal to 8. So once we take 2 and input it into f, this part here now becomes 8. We're then going to take the result of f of 2 and input that into g. And that looks like this. So g of x is equal to 7x. So we're going to replace the x with an 8. And this is going to equal to 7x. But since the x was replaced by an 8, it's going to be 7 times 8. And 7 times 8 is 56. So our final answer should be 56. You take 2 and you input it into f. You then take the result of that and input it into g. So g of f of 2 should equal 56. And if we check our answer, there it is. Now let's do a 2-star example. Here we're being asked to find f of g of negative 2. So just as we did in the previous example, we're going to take the input value, negative 2, and put it into g. We're then going to take the result of that and input it into f. And that looks like this. So we have g of x, we're going to replace the x with a minus 2, and g of x is equal to x minus 3. So the x, since it's replaced by a negative 2, is going to be negative 2 minus 3. This simplifies to give us negative 5, because minus 2 minus 3 is minus 5. Now, this is the result from putting negative 2 into g. It's negative 5. We're going to take this result and put it into f. So f of x is equal to x minus 11. But we're going to replace the x with a negative 5, which is the result from g of negative 2. f of negative 5 is going to equal negative 5 minus 11. And negative 5 minus 11 is negative 16. So therefore, f of g of negative 2 should equal negative 16. And if we check our answer, there it is. Now let's do a 3-star example. Here we're being asked to find f of g of 2 over 3. So the first thing that we're going to do is take the 2 over 3 and input it into g. And that looks like this. G of 2 over 3 is equal to 2 over 3 plus 7. In order to simplify this, we need to get this 7 to have a denominator of a 3, so we can actually add it to the fraction. So how we do this is we say 7 is equal to 7 over 1, which is true. We then times the denominator by 3, and therefore we have to times the numerator by 3 as well. This gives us 21 over 3. So 7 can be written as 21 over 3. So 2 over 3 plus 21 over 3. Now 2 plus 21 is 23, and then we have over 3. Now this is the result from inputting 2 over 3 into g. We need to take this result and input it into f. So that looks like this. F of 23 over 3 is equal to 6 times 23 over 3. And 6 multiplied by 23 over 3, well, if you remember the lesson on finding fractions of amounts, we can take the divided by 3 and apply it to the 6 first. So 6 divided by 3 is 2. And then we're going to multiply the remaining value, which is 23. And this is going to give us 46. So our final answer, f of g of 2 over 3, should be equal to 46. And if we check our answer, there it is. And that's it for the lesson on composite functions. Remember, a composite function is a function of a function.